uh, topic number 8 in S1, discrete random variables. And after completing this chapter, you should be able to understand what a discrete random variable is. You should be able to understand how discrete random variables arise. You should be able to find the cumulative distribution function of a discrete random variable, and we should be able to find the mean and variance of a discrete random variable. We should also be able to use the discrete uniform distribution. And under 8.1, before we start understanding anything in this topic, there are some fundamental information that you should be having before we even start explaining or understanding what is in the discrete random variable as a topic. And under 8.1, we are told that a discrete random variable can be described as a value obtained by taking a measurement from an experiment in the real world. So a random variable must take a numerical value. And moving forward, we are going to highlight several important information that you should be able to understand, and let's number them up. The very first statement that you should know is a variable is represented by a symbol X, Y, A, B, whatever it is. A variable is always represented by a symbol. This symbol, it can be X, it can be Y, it can be A, it can be B, it can be anything. Second statement, or rather point number 2, that when the value of a variable is the outcome of an experiment, the variable is called a random variable. When the value of a variable is the outcome of an experiment, when the value of a variable is an outcome of an experiment, then it is the variable is called, then the variable is called a random variable. A random variable, only when it is from an experiment. It is important to note that. Point number 3, another name for the list of all possible outcomes of an experiment is actually a sample space. We'll talk about a sample space. This is another name we can call all possible outcomes of an experiment. It's called a sample space. This one is not new. We have seen it in probability, and we all know what it is. Sometimes you may want to differentiate between a random variable X and one of its values. And under that, it is important to understand that capital letters like X are used for the random variable, and a small letter such as small x for a particular value of the random variable. So X, capital X, is actually the random variable. What about while small x is a particular value of the random, small x is a particular value of the random variable. of the random variable. Now, the probability that x is equals to a particular variable x is written as, sometimes it is important to note that you can also talk about probability. The probability that the capital X is equals to small x is written that way. We'll explain further when we get to, and both of these are interchangeable. For a random variable x is a particular value of x, and the probability of x is equals to small x refers to the probability that x is equals to, this refers to the probability, this is probability that x is equals to small x, probability that x, capital X, is equals to small x. Now, random variables may be discrete or continuous. Random variables may be discrete or continuous. So what is continuous data? A continuous random variable is one where the outcomes can be any value on a continuous scale. Continuous random variable, continuous random variable is continuous random variable is one where the outcomes can be any value, is one where the outcome can be any value on a continuous scale. What does continuous scale include? Decimals. This one we can talk about. It includes decimals, because when we talk about decimals, then that becomes continuous variable. What about discrete variable? Point number 7. A discrete variable, random variable, takes only values on a discrete data. A discrete random variable, takes only values on a discrete scale. Discrete scale. And what is discrete scale? The discrete scale is something that can be countable. Most of these will talk about whole numbers. Something that can be counted. Variables that can be counted, like the way we talk about the natural numbers 1, 2, 3, 4, and so on and so forth. So in this particular chapter, we will only deal with random discrete variables. In the whole of this chapter, we will talk about random discrete variable. We may mention here and there about continuous discrete variables that are going to assume some values, but mainly we are going to concentrate our focus on random discrete variables. All right?